Okay, this is called special right triangles. Today we're only going to do one type of special right triangles. There's actually two of them. So everybody listen, please. Just come sit down, okay? I'm in the middle of talking. Just come sit down. Everybody with me?
Yeah.
There's two types of special right triangles. We're going to talk about one of them today. And let's write it down. Shh. I'm in the middle of teaching, guys. The first one's called a 45, 45, 90 triangle. Let me draw one for you. So what do you think the 45, the 45, and the 90 represent? The angles, exactly right. It's the angles. I didn't measure this out exactly, but it's pretty close. So here's what we have. First of all, there's the 90 right there. So what do you think the 45 and the 45 are? The other two angles, that's right. So this is 45 degrees, and this is 45 degrees. I know it's been a minute since you've had geometry, but I'll review quickly here for you. If you have a triangle and you have two equal angles inside of that triangle, we learned something way back in geometry that the opposite sides are also going to be equal to each other. So what must be true about the length of this side right here? We'll call this, I don't know, we'll call this A, we'll call this B, we'll call this C. So what do you know about A and B? If this is 45 and this is 45, what do you think is true about A and B? They're both, well, they're not 45 because this is the length. They're equal to each other. They're equal to each other, okay? And we show that they're equal to each other by putting a little mark through it like this. We call that a tick mark. I don't know if you've seen that before. Probably have. All right? So if I know that you have a 45, 45, 90 triangle, that means these two sides are equal. So if I could find what A is equal to, then what's B going to be? The same thing. Same thing as A. All right? So that's kind of nice to know that A and B would be equal to each other on this. Everybody with me? All right. So what we're going to do is we're not going to, I guess we could call it A and B, but what we're going to do is we're going to call this the leg of the triangle. So that's one leg. This is another leg. And you should know what the C is. We've talked about the C when we did the Pythagorean theorem. What do we call that? The hypotenuse. And I'll just shorten it, just put HYP for hypotenuse. All right. Now there's a relationship. I'm not going to show you where this relationship comes from. Okay. I am just going to show you what it says. Hope you're watching. Hope you're taking notes. Because there's no way in the world, if you're not taking notes on this, that you're going to remember this. Okay? I'm just warning you right now. So you need to take notes on this if you want to have any chance of getting this right on the quiz on Friday. So, here's what we have. We say that the hypotenuse, this is only true about a 45, 45, 90 triangle. Okay? It's only true about this special type of right triangle. The hypotenuse is equal to the square root of 2 times one of the legs of the triangle. It's supposed to be an E. Let me try that again. All right, there it is right there. That's the first thing that you're going to need to know. You're going to have to memorize that. You got to know. I could show you like why that's true, but I don't think you're all that interested, especially this time of year. But I'm just showing you that this is the relationship. There is a way to show why this is true, but just take my word for it. I hate to do that, but take my word for it that that is true. So let's do an example. So I'm going to draw another 45, 45, 90 triangle. And again, I'm trying to make those legs the same. I don't know if they are exactly, but they're close enough for what we're doing. So there's a right triangle. What if I just said that this side, this, and this side were equal? And I didn't say anything about the other two angles. What do you think must be true about these two angles right here? They're going to be the same, okay? Because if you have two equal sides, then the angles that are opposite those sides are also going to be equal to each other. And if these two are exactly the same, then they have to be how many degrees? They got to be 45 degrees. That's right. So this has to be 45, and this has to be 45. Everybody with me? All right. What if I said that this, let's make up a number, just 5. What if I said that that side was 5 right there, and I asked you to find all the missing stuff to the triangle? So what's missing? Well, this side down here is missing, right? And this side right here, this hypotenuse, that's missing, right? And so I need to figure out what it is. Now, you could use Pythagorean theorem if you wanted to find this side right here. But there's an easier way to do it. And that's why we're learning this stuff, because when you have a special right triangle, and these type of triangles show up a lot in real life, okay? There's a lot of times when people are building things, when you have architects that are designing things, and you have carpenters that are building things and cutting things, you're going to see 45-degree angles a lot when you do stuff like that. So 45, and you'll see 90-degree angles. If you look in here, there's 90-degree angles all over the place in this room, all right? And there's also 45-degree angles a lot of times. And so this is very, very common. It shows up a lot. So we don't have to do Pythagorean theorem to find this. We could just use our little formula right here. So first of all, if I call this A, and I call this B, and I call this C, and I want to find what B and C are equal to, what's the easiest one to find right now? B, because it's what? It's the same as A. So if A is 5, then what's B? It's 5. So that's really easy. Everybody in here can do that. These two sides are equal to each other. If they give you one, then the other is going to be exactly the same thing, right? Not that big of a deal. Well, to tell you the truth, the hypotenuse is really not that much more difficult at all if you know that formula. So what is the hypotenuse then? The hypotenuse is what? The square root of 2 times one of the legs. Do I know one of the legs? Yeah, absolutely. It's 5. So how do I multiply 5 and the square root of 2? Is it the square root of 10? 5 times 2? No, because 5 is just a whole number. 5. How do I multiply by a square root of 2? Just stick it right next to a square root of 2. That's all I do. It's as simple as that. What do you think? It's pretty easy, isn't it? Yeah, absolutely. If I give you one of the sides, this is the easiest version of this problem. Okay, I'm going to show you a couple different versions of it, but this is definitely the easiest version of this problem. If I give you one of the legs, to find the hypotenuse, all you do is take the leg and multiply it by the square root of 2. That's it. Everybody in here can do that. Would you agree? Sure. All right. So let's take a look at another version of this. I should have just copied that triangle. I wonder if I have it up here. Maybe not. Do I? Oh, yeah, there's it. That kind of looks like a 45, 45. Let's just use that instead of me drawing it every single time. Yeah, it's pretty close. I don't know if I can grab it. Come on. Tell you what, let's just do this. Make it a little bit bigger. There we go. All right. And this is a right angle. If these two sides are equal, that must mean that's 45, and that's 45 right there. What if I said the length of this side? Now, this is kind of weird. All right, you don't see this like architects and things like that. They use square roots, but they would normally put it into a calculator to get a decimal answer. But in math, we learn how to deal with square roots. So let's say this was, instead of 5, let's say it's the square root of 5. What is that? What's the square root of 5? I don't know. That's not 5. Like, what times itself is equal to 5? I don't know exactly what it is off the top of my head. I don't know what it is, but I know it's close to what? Quit using your calculator. What times itself? 2 something. That's right. That's what I wanted to hear. 2 point something. Now you can use a calculator. Who's got a calculator? Landon, you got one. What's the square root of 5? 2 point what? It's probably 2 point something small. Square root of 5. 2.2 something. Okay, so I figured it was 2 point something small. So the square root of 5 is actually 2.2 something something something. All right, so it's a number. All right, a lot of people don't like the square roots, but it does represent a number. All right, so what if I asked you to find the other missing sides? What would this side be right here? Without any work whatsoever, what's this side right here? Square root of 5. That's right, because they're both exactly the same. Everybody got that? Now, to find the hypotenuse is just a little bit more difficult. Not much, but just a little bit tougher. So, how do I find the hypotenuse? Do you remember what the formula was? The hypotenuse is equal to what? The square root of 2 times what? One of the legs. Do I know one of the legs? Yeah, square root of 5. What do I do with that square root of 5? That's right. So how do I do that? Let's do the math over here. So I take the square root of 2 times the square root of 5. Do I just leave it like that, like I did when it was a regular 5? No. When it's two square roots multiplied, we've talked about this in here several times before. When there's two square roots multiplied together, what do? We just make one big square root. And what do you think we do to that 2 and that 5? Just multiply them together. And what is that? It's just 10. So what's the square root of 2 times the square root of 5? It's the square root of 10. Okay? So what's the hypotenuse? Square root of 10. That's it. So it's a little harder than the first version of it, right? It's not much, just a little bit. What do you think? Let's do another one. Let's do this. What if I said that this was 2 times the square root of 3? Now, it's 45, 45, which means this side and this side are equal to each other. I'm not even going to put the 45s in here. If I know these two sides are equal to each other, automatically it means those two angles are 45 degrees. So what if this was 2 square root of 3? What's this going to be? It's going to be 2 square root of 3. So we got that part down, don't we? Right? If you know one leg, the other was going to be exactly the same. What about this, though? The hypotenuse. Well, what do we do to find the hypotenuse? We just take this and do what to it? Square root of 2. That's right. So let's do the math over here. So it's 2 square root of 3 times what? The square root of 2. Now, how do we do that? Sure you do. The whole number, you can't really do anything with the whole number. So you just put the 2 right there. But what do I do with these two right here? It's exactly right. It's the square root of 6. So you just keep that whole number 2 out front, and you multiply those together, put them under one big square root, and it's the square root of 6. It's not hard, is it? Yeah, I think everybody can do that. I don't think anybody has a problem with that. So what does that mean? Why did I do that? Why did I multiply that by the square root of 2? Because that's how you find the hypotenuse. Exactly right. So what's the hypotenuse then? 2 square root of 6. And they're going to ask you to find the exact values. Okay, the exact value means you have to keep it in the square root. It's not taking this and putting it into a calculator. Everybody with me on that? All right, so it's finding the exact value, and that would be the exact value right there, 2 square root of 6. So that's my answer for that hypotenuse. We good? I can't think of any, in that particular type of situation, any other variations of that. But there is another variation of the 45, 45, 90. And let me show you that. All right. I'm going to write that formula down again. If you can't remember hypotenuse is equal to square root of 2 times the leg, write it down every single time you do one of these problems. So if I'm doing another problem, guess what I'm writing down if I can't remember it? I'm writing down this every single time. You write that down 3, 4, 5, 6 times, you're going to remember it. Okay? But if you just write it once and refer to it, that's helpful, right? You write it at the top of the page, that's okay. But writing it down every single time is going to help you remember it. Because tomorrow, we're going to learn another type of special right triangle, and there's going to be 2 different things to remember about that triangle instead of just the one. All right? So it's very, very important that you get this down today, because tomorrow, we're going to do 2 different things instead of just the one. That's all right. Yes. All right. So let's do this. Let's put another triangle right here. And we'll just keep it the same direction. Doesn't make any difference. Put it right here. Now this time, now what did I always give you? Right? This side and this side are equal. On the problems that we've done so far, how many different examples do we do? Like 3 of them? So what did I always give you? I gave you the leg, didn't I? So what do you think I'm going to give you this time? I'm going to give you the hypotenuse, okay? Now watch. I am going to make the hypotenuse look kind of weird, but it actually makes things a little bit easier for us. I promise you. So let's make this, I don't know, the square root of 6, okay? And what I need you to do, I need you to find what A and B are equal to. Well, if I find 1, then the other is going to be the same thing. Is it going to be 3? Square root of 3? How'd you get that? Right, this time, what do? Instead of multiplying by the square root of 2, what are we going to do? We're going to divide by the square root of 2. And why is that true? Well, let's use our little formula up here and show it. So that's good. I'm glad you saw the division. All right, so what's the hypotenuse? Square root of 6 equals square root of 2 times one of the legs. Which leg do you want to solve for? Let's solve for A. See what I did? I just plugged in all the stuff that I knew. I knew the hypotenuse, so I stuck in a square root of 6 for that. I wrote down square root of 2, and I wrote down what my letter was for the leg. Now, some of you guys saw automatically, if they give you the hypotenuse, how do you find the leg? You would divide, right? And this is why you divide, because of this thing right here. So to get A by itself, I divide by the square root of 2. And then let's solve for A. Now, do you remember? Don't leave it like this. I circled it, but that doesn't mean it's the final answer, okay? If I multiply two square roots together, guess what I do? I put one big square root, multiply them, stick them under the square root. What if I'm dividing two square roots? What do? I make one big square root and then do what to these two? Divide them. That's right. 6 over 2. And what is 6 over 2? It's a 3. But it's under a what? Square root. So what's A equal to? It's the square root of 3. Okay? Now, once you find one, the other one's super easy because it's going to be the same exact thing. So hopefully you got this one right, and then you'll get this one right. What's B equal to? Square root of 3, because they're both the same. So that's a little trickier, just a little bit. But you knew it wasn't going to be as easy as the first one we did, wouldn't you agree? All right. And that's how you do it. So if they give you the hypotenuse, what do you do to find the leg? You divide by the square root of 2. You don't have to go through all this if you don't want to. But you got to know, you got to take this and divide it by the square root of 2. I got one more to do. Ready? Let's make it a little bit bigger so you can see it. Come on. There we go. Now, by me making that hypotenuse a square root, actually made things work out kind of easy, especially since this 6, you can divide it by 2. All right, so I made that situation as easy as I could. What if I had something like this? What if I had this, and I said that this was, let's say it's 10, and I asked you to solve for A and B? So what are you going to do? What did we do before when it was a square root of whatever I said it was, 6? We divided by the square root of 2. What am I going to do with this one? I'm going to divide it by the square root of 2. Okay, but something happens when you divide by a square root, especially a whole number. So let's do it. Let's do the whole thing. I'm going to write it down again because we're kind of new with this, right? Does anybody remember doing this back in math class, in geometry? I got one person, only 2 people. Okay. Well, I'm teaching this as if you've never seen it before. Okay, so I'm not making any assumptions that you know how to do this. So let's put everything we know into this formula. Do I know the hypotenuse? Yeah, it's 10. So I put a 10 right there. Square root of 2, I'll just put right there. Which leg do you want to solve for? Yeah, let's solve for A. Doesn't matter. You can put B in here. It doesn't make any difference. Okay. So what are you going to do to get A by itself? Divide by the square root of 2. Some of you guys could look at this and say, oh, if they give you the hypotenuse, how do I find the leg? I just divide by the square root of 2. If they give me the leg, how do I find the hypotenuse? If they give me the leg, it's the first ones we did. How do I find the hypotenuse? I multiply by the square root of 2. You with me? So if they give you this side, you multiply it by square root of 2 to get this. If they give you the hypotenuse, how do you find the leg? You divide by the square root of 2. Okay? The problem is, do math teachers like you leaving it like this? We've had this discussion before. Why not? Why is that not okay to leave it like that? Because I have a what? Square root on the bottom. Okay, I got a square root on the bottom in the denominator. Math teachers don't like that, so we got to do something to get rid of it. Again, this is not new. We've talked about that on several occasions in here. So what do? You remember? We multiply it by something. Something over something. It's not really a conjugate. It's not really reciprocal. Just multiply it by the square root of 2 over the square root of 2. Everybody look. You guys seem like you're losing me. Let's hang on. Why can we do that? Well, because what's anything divided by itself? It's equal to 1. So do I change the value of this by multiplying by a 1? No, I don't change the value at all. Okay. Why did I pick the square root of 2? That seems kind of random. But was it random? It really wasn't, because I want to get rid of that square root. So if I take the square root of a number and multiply it by the exact same thing, it's going to get rid of the square root. Okay? You hear what I just said? If I take the square root of a number, and if I was to multiply it by the exact same number, it gets rid of the square root. All right? You remember this, don't you? Yeah, we've done this before. You might have even had this on a quiz or two. Watch. What's the square root of 2 times the square root of 2?
2.
It's just a plain old 2. That's right. You just get rid of the square root, and you're just left with a 2. That's very simple. Remember me doing something like this? What's the square root of 5 times the square root of 5? It's 5. What's the square root of 17 times the square root of 17? It's just 17. Everybody watching? All right, let's pay attention here. So the square root of 2 times the square root of 2 is 2. So what do you do when you multiply the top here? It's 10 square root of 2. Do we leave it like that? Do we circle it? What do we do? Here. 2 divides into that 5 times. So your answer is 5 square root of 2. That's what A is. It's 5 square root of 2. B is 5 square root of 2. Okay? Let's just do this. I think we actually did one, didn't we? Where we used 5. No, we didn't. That's okay. Look right here. Almost done. Let's see. What if, and that's your answer. Okay, that's what that side is, and that's what that side is right there. Let's just double check to see if that works. What if they didn't give you the 10? What if they just said this side was 5 square root of 2? How would I find the hypotenuse? Right, you take the leg, you multiply it by the square root of 2. Let's see what we get. 5, what's square root of 2 times square root of 2? It's 2. It's 5 times 2. It's 10, just like it should be, shouldn't it? So that does work, doesn't it? All right. That's about as hard as this problem gets. All right. Is when they give you a whole number for the hypotenuse and you got to find this, you're still dividing by the square root of 2, but you have to simplify it. Okay. This stuff right there, it's really important because when you go to college, if you have a class and you're doing some of this kind of stuff, this is very, very common stuff on a first year math course in college. Okay. If you have something like this, your math teacher is going to make you simplify it. All right, and they're not going to let you keep it 10 over the square root of 2. They're going to make you simplify it to this. So 10 divided by the square root of 2 is the same thing as 5 times the square root of 2. All right? So that's it. I'm going to give you some problems to do. If you look on the worksheet or the lesson plan thing, I didn't give you like 1 through whatever, right? Yeah, 1 through 6 and then 13 and 18. Because I'm only going to give you the 45, 45, 90. There's the other parts are these other triangles we're going to do tomorrow, which is called a 30, 60, 90 triangle. Don't do the ones with 30 and 60 in them. Only do the ones with 45 and 45. Everybody understand? We'll do the second part tomorrow, and that's what we'll do tomorrow.